Welcome back to my channel. Today we're going to be talking about the breadth first search pattern. So the last time we discussed about the DFS pattern, which is the depth first search pattern. Today we will talk about another form of tree traversal, which is the BFS pattern. Yeah, so now basically we follow the same pattern. Yeah, if you imagine that the breadth first search pattern this time around, so let me just say BFS, breadth first search. So the B there means breadth and then first search. So many of the things that we explained the last time still matter here. Yeah, that's why I've left the documentation from the previous discussion. Yeah, so the same pattern will apply on the same tree structure. We'll have this tree structure, but the difference now will be how we explore this tree. Yeah, so the traversal of this tree. So BFS is usually very important, right? When it comes to traversing trees, one level at a time. So what that means is if you imagine that this person, this guy we had here before. Yeah, so let me just make a copy of this so that so what's this? Yep. Okay, let me just move all of this some down. Yeah, so now what happens with BFS is imagine that this guy is here. Yeah, so what we do is instead of exploring all the way to the depth like we did in DFS, we went all the way to the depth and we printed them in different ways, but basically we went all the way to the depth. When it comes to BFS, what we will do is we'll explore the nodes that are directly linked to the current node that we are on, first of all, before we go to the next. Yeah, so what that means is we'll start from 1, then we'll check 2, and we'll check 5. Yeah, those are the nodes that are directly visible to this guy standing at node 1. Yeah, so when it comes to printing out like we've done before, what we actually do is we land there, we print out a value 1, then we immediately look at the nodes that we can see look starting at 1, and those are 2 and 5. So we print out 2, we print out 5. Yeah, so now if you picture that we are now once we go down, we are now like on this level. So this level means that we are here, and then we can see everything that is down. So looking from here, looking downwards, we can see all of these fonts. Yeah, and then basically we then print out 3, 4, 6, and 7. And so this is BFS pattern, right? If we really understood how the DFS pattern works, we will realize that this one is a kind of different kind of traversal when it comes to this graph, and it has a name. Yeah, so that name is level order traversal. Level order. So if you imagine that this is like level 0, the topmost level, then the next level here is level 1, and then the next level here is level 2. So what DFS helps us to do is it helps us to explore the nodes that are in a particular level at the same time during one go, and then explore the nodes in the next level in one go. Yeah, so it also helps us to search, just like the DFS does. However, it's really peculiarly important for problems whereby we need to find maybe like the shortest way to arrive at a node, or the fastest way to arrive at a node, or like there's some form of proximity search to it. Yeah, so that's where BFS helps us. Right, but then unlike DFS, the DFS doesn't have anything to do with proximity. Yeah, it just helps us explore a node all the way down and then see the entire extent of it. Yeah. So yeah, so when it comes to the traversal, let's see if I can come up with a pseudocode here. So when it comes to the level order traversal, we are going to be on a node. We're going to evaluate the value inside that node. Once you evaluate the value of the node, then we are going to now evaluate the value inside, like the value of all the children nodes of that node. And then once we are done exploring that level, then we're going to evaluate the next set of children. This is basically what the breadth-first search and level order traversal is all about. Yeah. So the last time I spoke about how we would explore all of the nodes in the DFS. Yeah. So for pre-order, in-order, and post-order, I did say that, for example, when we're doing in-order traversal, when we go left first, then we need to now repeat the whole process all over again, the exploration process all over again on the left node. We need to keep going left until we can no longer go left. Yeah. So that process is recursion. And recursion is a pretty recurring theme when it comes to BFS patterns generally. For pre-order, in-order, and post-order, we have some form of recursion going on. Yeah, so recursion. So recursion basically is how a function calls itself, right? So you can see how we have this repeating function, this exploration function. It's being called all over again. It's calling itself the same function, the same function definition. Yeah, so yeah, so that is one way, to implement this DFS. However, there's another way to implement DFS, and that implementation is an iterative approach. So this is another pretty popular question that you might expect. Right, so this iterative approach to implementing DFS basically now says that rather than using a function that calls itself, yeah, so let me just write function calls itself. Rather than using a function that calls itself, in this case, we would use a loop. Yeah, so whether it be a for loop, a while loop, or a do while loop, whichever kind of loop that you want to use, we basically implement this using a loop. Yeah, and um, I think I should just give a little hint when it comes to this kind of loops. Yeah, I'll probably drop a question in the comment in the description that relates to solving these kind of problems. Yeah, but just think about a stack data structure. You're going to keep these elements on a stack and you're going to explore them in a pretty smart way. Well, basically, it allows us to not use recursion, it allows us to use a stack. All right, so now when it comes to BFS, so for BFS, recursion has no, like, you cannot implement this using recursion. You know why? Because when it comes to recursion, you need to go down and then you're going to land there, you're going to now repeat the same process all over again. For BFS, remember that what we do is not go down, right? When we go down, we explore all the nodes in that level at the same time. Yeah, so usually is implemented using an iterative approach. And this iterative approach is usually done using what data structure. If you think about it, stack, yeah, remember stack is the last in, first out data structure. What data structure is in this case is going to help us for this? It's a queue. So we can implement BFS using a queue like data structure. And yeah, I think that is all for this session. I hope you guys have been able to pick up a few things. I would share some questions related to BFS pattern and what we've discussed today. And yeah, hope you guys had a nice time. Please don't forget to like, share, and subscribe. I'll see you guys in the next session where we'll be talking about the next pattern on this list, which is the matrix traversal pattern. Alright guys, bye.